For the last couple of sessions that we are going to be working on here in Math 99, we're going to take 2 sessions and work on a little bit of probability, okay? A little bit of probability. Probability is basically, the probability of something happening is basically what you want out of the total possible. That's the best way I can describe it, okay? It's what you want out of the total possible. Now, a lot of people get confused on probability. You have to be a little careful about getting your total possible. For instance, a coin is tossed 3 times. You could get 3 heads, 2 heads and a tail, 1 head and 2 tails, or 3 tails. So some people say, oh, there's 4 things that can happen. So the total possible is 4 things. We're going to find that that is not true. What is the probability of getting 2 heads and a tail? So you might be tempted to say, well, if there's 4 ways it can happen, what's the probability of getting 2 heads and a tail? Is probably 1 out of 4. But that is not so. Because individually, if you look at these 4 different things, there's different things that can happen. Like 3 heads, there's only one way that's going to happen. Head, 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 head. Or 2 heads and a tail. You could have the first 2 coins come up heads and the last one tail. You could have the first one head, the middle one tail, last one's head, or the first one tail and the last 2 heads. You see, 2 heads and a tail, there's actually 3 different ways that could happen. The same thing with 1 head and 2 tails. You could do the same thing. A head and 2 tails. This or this. And then 3 tails would simply be tail, tail, tail. So instead of 4 ways it could happen, there's exactly 8. Okay? So what is the probability of getting 2 heads and a tail? It would be 3 possible. What you want, 3 of these out of 8. That's the probability. The easiest thing to do then is change that to a decimal. So 3 divided by 8 is 0.375 or 37.5% of the time. Okay? A coin is tossed 3 times. Same thing. List the possibilities. I've done that. Now find a probability of getting 2 heads and a tail. That's just what we did. 2 heads and a tail right there. Find a probability of getting exactly 2 heads. Exactly 2 heads is still this, still 3 out of 8 or 0.375. Probability of getting no heads would be all tails, 1 out of 8, which is 0.125 if you divide it out. Fewer than 2 heads. Fewer than 2 heads could be 1 head or no heads, which is 4 out of 8. Or it's a 50-50 chance. 50% of the time you can do that. No more than 2 heads. Could be 2 heads, could be 1, could be none. No more than 2. So it can't be this one. So there's 7 out of 8, which is 0.875 or 87.5% of the time. No heads and no tails. That's impossible. 0. If something's impossible, it's 0. If something is guaranteed, like suppose I said either getting a head or a tail. Well, that's going to happen all the time. You're going to get a head or a tail. That'd be 100% chance. Okay, so if it's impossible, it's 0. If it's guaranteed to happen, it's 100%. Let's move on down. Okay, let's talk about dice. Keep the same formula up here for probability. Let's talk about dice. 2 dice are tossed. List all the possibilities. Now, let's say you have a red die and a green die. Suppose a 1 comes up on the red die. Here's the red. Suppose a 1 comes up on the red. You could have the green coming up with anything 1, 2, 3, 4, 5, 6, right? Suppose comes up a 2 on the red. You could then have 1 through 6, and so on and so on and so on. Now, what I'm going to do is I'm going to list these. So you could have a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. Or you could have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. It's going to take a while, folks. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You could have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Or you could have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. 6 rows with 6 in each row. There's 36 different possibilities, okay? Find the probability of getting a sum of 7. We know the total possible is 36. We want a sum of 7. Well, like a 4 and a 3, a 3 and a 4, a 5 and a 2, a 2 and a 5, a 6 and a 1, and a 6 and a 1, a 1 and a 6. So there's 1, 2, 3, 4, 5, 6 ways you could get a 7. So it is 6 out of 36. You should divide that out, get a decimal. 6 divided by 36 rounds off to about 0.17, or 17% of the time you'll get a 7. How about a double? A double is when you have the same thing, like 2 and 2. So here's 1, 2, 3, 4, 5, 6. Same thing. It's going to be 0.17, just like getting a 7, getting a double. How about a sum of 7 or 11? Could be 7, could be 11. 7, we know that there's 6 of them. How about getting an 11? Isn't an 11 getting it is either a 5 and a 6 or a 6 and a 5? Okay, so because I said or, you could have 6 of the 7s or 2 of the 11s, which would make a total of 9 out of 36. If you divide that, it's 0.25 or 25% of the time. Okay? What about if I said you could get a sum of 2, of 3, or 12? To get a 2, it's 1 and 1. To get a 3, it would be 1 and 2 or 2 and 1. So you have 3 possibilities there, and a 12 is a 6 and a 6. Okay? That's a total of 4 out of 36, which I think if my brain is working, 4 divided by 36 is 0.11 or 11% of the time. Okay? Or you kind of put them together. A sum of 8 or a double. A sum of 8. How about a sum of 8? Could be 2 and 6, 3 and 5, 4 and 4, 5 and 3, 6 and 2. Kind of neat the way they're on a row here, a diagonal. 1, 2, 3, 4, 5 ways of getting an 8. Or a double, we said there were 6. Now, you got to be real careful here. There's 5 ways of getting an 8, 6 ways of getting a double, makes a total of 11 out of 36, right? But what did I do? I counted one of them more than once. Did I not count the 4 and 4 in both sets? So you can't count it twice, all right? So if you count 1, 2, 3, 4, 5, there's 5 ways of getting an 8. Then there's a total of 6 ways of getting a double. You cannot count that, so now there's only a total of 5. So it should be 5 and 5, or 10 out of 36. I don't know that one. 10 out of 36 is 0.28, or 28% of the time. What about a sum less than 5? Sum less than 5 could be 2, could be 3, could be 4, and it's got to be strictly less than 5, so it can't be 5. So it could be this one. Either of these 2 or either of these 3 makes 1, 2, 3, 4, 5, 6 out of 36, and we're back to the 0.17. A sum bigger than 9, exceeding 9. Look at the 9s. 6 and 3, 5 and 4. The bigger ones would be 10s, 11s, and 12. So 1, 2, 3, 4, 5, 6. 6 out of 36 again is 0.17. Now, I want to do a little bit with you with this whole concept of and or to make sure you understand and or, because you're going to see them in some of your probability problems that we get into our next time together. Okay, so here in problem 5, this is, sorry about this, we're going back to algebra a little bit, but I want you to understand the difference between and or, okay? For instance, if I have a number line, here is 3, here is 5. Bigger than 3 is open and shaded to the right. Notice how I'm putting the answer up above, and then I'll put the final answer right on the number line. Less than or equal to 5 could equal 5, but it's less than is down. If you tell your parents, this weekend, I'm going to do my math assignment and I'm going to go to the movies. The only way you can be telling the truth is if you do both. If you do your math assignment and you go to the movies. So you look here and you say, where am I telling the truth? In both of these situations would be right in between. So the final answer for an and problem is where you're telling the truth on both of them. Now, if you say or, this weekend, see this next problem is an or. This weekend, I'm either going to do my math assignment or I'm going to go to the movies. I'm going to either do one or the other. One or the other. The neat thing about mathematics, or means it's one or the other, or you could do both. It's not a problem. Most of the time when we say the English sentence, I'm going to do this or this, we don't mean both. But in mathematics, it can be both. So what is or? Could be this one, could be this one. So if you were doing an or problem in this one, where this is 3 and this is 5, an or problem, it's you just toss the two together. Ors are really easy because you just put the two together. And you have to be really, really careful because you want to get where you're telling the truth in both of them. All right, next one. Less than 3, less than or equal to 5. All right, here we are at 3, here we are at 5. Less than 3 is open and down. Less than or equal to 5, closed and down. It's an and problem. Which part of the graph are you telling the truth for both of them at the same time? Right here, you see where the overlap is. Make sure this is open. And then it goes to the left. Okay? Notice here it's an or. If it's an or, you simply put both of them together. You simply put both of them together. And you would start here with a solid dot. Putting them all together just shades everything to the left. Let's go down to E. E. Here we go again. 3 and 5. We want less than 3 is open and down. Bigger than 5 is open and up. Yeah? Okay? Where are we telling the truth both cases? Here we're telling the truth for the less than 3. Here we're telling the truth for bigger than 5. There's nowhere where there's overlap. There's nowhere where we're telling the truth and doing both of them. So there is no answer in this particular problem for an and. But if it was an or, it could be this one or it could be this one. So you have to put both parts. Okay? All right, so there's our first session on probability. Your assignment will be all probability problems. And we will have one more topic in probability to do, and this course will be over except for the final.